What discoveries in neuroscience and cognitive science do you think will have fallouts that are beneficial to progression in strong AI development?
Well, I think cognitive sciences, they tell us a bit about ourselves. And any, anyone that wants to relate to us better, the more they know about us, the more they can relate to us better. So cognitive sciences, understanding of the human visual system, understanding of various, the way problems are solved within the brain, the way we perceive things, how much we tend to adopt an ideology to the detriment of observation, optical illusions. All of these things are, I think, important because they characterize us. And if we want to make an artificial general intelligence, for us to consider it to be an artificial general intelligence, it really has to be to some degree like us. People don't consider a chess-playing computer, which is very specifically intelligent. Even when they're playing chess, they don't really consider it like us. They see it as something else. Because it doesn't have those same characteristics, which are in some cases failings, that make us. So I think any study of us is going to benefit systems that want to emulate us and communicate with us. But I personally believe in terms of pure problem solving, they are really an observation that the systems would ultimately incorporate for the purposes of expediting communication, but are themselves, in many cases, they're things that we don't necessarily want. We don't want to build our faults into our creations. And the trouble is, if you reverse engineer the brain and create something from it, yes, that's good. You've got an AI that seems to be working like us, but it may not be the best it can be because you've simply replicated our faults and our psychological blindnesses, which are legion, where we see things that aren't there or don't see things that are there. And I don't just mean visually, I mean at all levels of cognition. So I think to study the human mind is obviously a valuable thing. It can provide us heuristics, as we were talking before about specialization of subparts of the neural network. Certainly it can provide information as to pre-processing of inputs, so as to pass the inputs to the processing element in the same way they are done in a human, which will help us to understand our creations and vice versa. But in the long term, I think it's a pure theory of problem solving that we want, not necessarily a pure theory of how humans solve problems, which is a subset of the bigger picture.
Well, what do you think about friendly AI? And what do you think are the most important aspects to consider when building a general intelligence which favours us, or at least has which is beneficial towards the human race?
All right. The only mechanism that you can use to create a friendly AI is empathy. I think all else is folly. So you're asking about friendly AI.
Okay, so yes, asking about friendly AI, beneficial AI, and AI that's generally nice.
If you meet a person, are they friendly?
Not always.
Okay, not always. Now, when it comes to AI, because of the recognised power that if you meet a hyper-intelligent person, I say, are they friendly? You say, not always. But of course, you recognise that there's a lot more danger in a hyper-intelligent, non-friendly person than there is in a normal, non-friendly person, correct?
Okay.
So we've got to accept the possibility that hyper-intelligent AI can be dangerous in some way, shape or form. So the question remains, how do we constrain that to doing things that are good to us? And there are many dimensions to this problem. The first one being, who's us? Is the terrorists that we might turn the system against certainly not going to be friendly to them, or if it's friendly to them, it may not be friendly to us, or if it's created by a large financial company, then it might be friendly to the company and make their share price go up, but it does so to the detriment of everyone else. So I think the first problem we have is the definition of scope of who us is. Let's just say that we want a system that the majority of the people surviving consider it to be good or friendly in some way. And I think the clear answer to that is that we have to make it in some way empathic. The problem being that given that such a system should be able to create systems smarter than itself in the same way that we have created it, which is smarter than us, then you must prevent some kind of ideal of goodness, whatever we define as goodness, from being thrown out as these new systems come into existence. And surely the only way to do that is if you can make that system derive pleasure or happiness from our happiness and pain from our pain or our absence, so that both our pain or our absence causes it pain and both our happiness and presence cause it pleasure. And it would therefore, presumably, because its own pain and pleasure are now determined by our pain and pleasure, pass that on to its descendants. And it would also pass on the same things, because to create something that might be destructive of us or it would therefore contravene its empathic goals. To me then, the core to friendly AI is empathy. How do we make something that's empathic with us? And that's not necessarily that trivial, and it may require an understanding of consciousness. It's all very well to say that you're in pain. Our friendly tape recorder over there can tell you that it's in pain, but it's not. That you really have to feel the pain of another, and that may require this elusive subjective element, which we call consciousness, which we do not have a good theory on at this stage.
So do you think if artificial general intelligence came about now, would it be dangerous, inherently dangerous?
Well, clearly, because if it came about now, someone would have probably put in some of those idiotic laws of robotics or something which are meaningless, but which people seem to think we don't have a mechanism of constraint of such a thing at this time. Until we have an understanding of consciousness, which is clearly the most valuable thing we have. I mean, it would be totally irrelevant to keep the human race in some kind of utopian, blissful looking existence if there was no one inside their heads, if they were unconscious. So therefore, what we're trying to do is create some blissfully happy future conscious presence, which somehow involves us. So to do that, we have to understand consciousness, and I don't think we have a handle on consciousness at this stage. So any AI that comes out now may or may not be conscious. I suggest it probably wouldn't be conscious, and that I think that the current architectures that we're using cannot be conscious. They can certainly be good simulacrums of us, they can certainly be zombies, but I don't think they can be conscious. And as such, I don't think that they can necessarily empathise with us. They might be able to measure our happiness, but it's not quite the same as feeling our happiness. They can measure our pain. It's not quite the same as feeling our pain.
Okay, so what do we know about consciousness, and what don't? What do you think are the things we don't know?
Well, the only definite thing that I can tell you about consciousness is that I have it.
There's no way to measure it at the moment.
Well, that's the trick, isn't it? The objective measure of a subjective experience is what the study of consciousness is all about. We can identify neural correlates of consciousness, and a lot of work's been done in that field. We can say that this person appears to be conscious at this time, as is evidenced by the following neural firings, but that doesn't say that those neural firings are themselves in any way causal to that consciousness. They just say that those two seem to be happening at the same time, with the consciousness, whatever processes allowing this subjective inner world to exist. So, no, we do not have a good handle of consciousness. We have theories. Some of those theories would argue that the neural correlates of consciousness are all that is required en masse to create a conscious experience. But others, such as myself, say no, that the subjective conscious experience, the binding problem associated with consciousness, requires further explanation. And I, as you know, turn to quantum mechanics.
Okay, can you explain the binding problem and consciousness?
Well, in summary, the binding problem is that experience that you have of simultaneity, that things are happening around you all at the same time, all related to you, and that you are somehow binding that information together into your unified whole, which is your identity.
So it's not just necessarily the inner self, it's also your external world, which
it's very hard to reductionalize that concept. It's very hard to... We can sit down and we can take any part of the processing within the human brain and possibly come up with a rational description of how it's working, and saying, oh, this pattern is being turned into that pattern via that part of the neural network. But why does that give you a subjective experience? Where's the subjective experience coming from? We can see loops taking place in the brain where part of the brain is looking at another part of the brain. But of course, why does that give you the subjective experience? Look, there's a good reason they call it the hard problem. Because it's hard to even contemplate, let alone work out how to attack the problem. But I believe that the binding problem and problems similar can be addressed through quantum mechanics. Because in the quantum mechanic realm, space is, in some concepts, fictionalized, that there is no informational distance between objects. Do you want me to stop while that helicopter goes over? In quantum mechanics, the state of particles in disparate parts of space are enmeshed, they're entangled, they are related to each other at apparently instantaneous, or at least superluminal. They've measured this to X numbers of times faster than the speed of light. That doesn't mean that we can pass information, but it does mean that those disparate particles, those disparate points in space, are somehow linked as a whole. And I suggest, as some of the early physicists suggested, that this is part of the conscious experience, that this linking of space, disparate space, this binding together of space, is part of the conscious experience.
Binding together of space. Yeah.
You're asking a question about the discussions we've had where I've talked about neural races within networks, where a lot of neural processing seems to be to create bistable nets where the thing will either flip one way or the other. And that I see that ultimately that one of the indicators of this is thermal noise, quantum mechanical events that will, at a deep level, create decisions within us, that we basically process a decision to the best of our ability based on our previous experience and by modelling the consequences of our decision, and we continue that process to a finer and finer degree until we cannot make a decision, at which point we toss a coin. We have a bistable state, one side or the other pops out, and that tossing a coin is effectively the result of quantum mechanical processes within the brain, that is thermal noise. We then ascertain the consequences of our decision, which then gets reinforced and becomes either yes, we'll do that again, or no, we won't do that again. So we then learn. And this mechanism is what accounts for the fact that you really don't know what your decision is going to be until you've made it. That the reason that we see people make a decision before they become conscious of it, which are a very famous series of experiments, of course, that people appear to have made volitional decisions before they're conscious of making those decisions. And I tend to believe that the mechanism that I propounded to you before is an explanation for that. That our decision ultimately is either based on our previous experience or a coin toss. And then we are conscious of what happened. So what we call our decision is really a measurement of what happened after the decision was made. Our conscious experience is the consciousness of the decision that we've just made when we've tossed the coin. And of course, the more expertise you have in an area, the less conscious you are of it for this same reason, because you have already learned how to solve the problem. So there is no coin toss required. So there's no consciousness required. That if the problem is easily solved by your past experience, you can do it unconsciously. So when you say, I think a lot of the brain is designed to create these race conditions whereby you have a winner-take-all strategy, but in the same way that we handicap horses to try and get them to all finish close to the same, the brain does a similar thing and tries to get these neural race conditions to finish at the same point. If one horse is obviously better than the other, it wins the race. It's done and we don't even think about it. But of course the problem becomes more interesting when they're close. And so the brain is designed to solve the problem as best as it can, but then to get the extra mileage, the extra fine-tuning of the decision, then it comes down to a race condition, and then you have a toss of the coin, a quantum coin. And our consciousness is a result of looking at that coin toss. So it's retrospective to the decision.
Interesting. So, do you think, I've heard you say that it's a 50-50 coin toss, but is there can there be more than two competitors in this race condition? Or is it just less just highly unlikely. It's not
Yes,
worth
of course. Of course, and there might be many simultaneous races taking place.
Races within races. A coin toss between races.
Well, it's not quite like that. I would suggest that generally it comes down to a winner-take-all strategy. It doesn't have to be between two horses, but that would make more sense.
Some people suggest that friendliness is inherent in superintelligence.
Friendliness.
Would be inherent in superintelligentness.
Friendliness.
Yes.
Right.
Stefan,
Well,
okay.
those people are wrong.
Yes, right. Can you explain why?
Well, I can give examples.
Sure.
I mean, people look at predator drones, which are, say, smarter than little balsa-wood models that fly around, and they're smarter and they're less friendly. So that would tend to imply to me that superintelligence doesn't in any way. It's a different axis. It's to friendliness.
Mm-hmm.
Intelligent creatures have got no need to be friendly or unfriendly. Look at Machiavelli. Machiavelli was a very clever man, but as you said, my allegiance is to Florence. Right? That didn't help anyone else, right? But his hyper-intelligence was certainly a good thing for Florence, I presume, and as a philosophy. No, friendliness is a completely different spectrum to intelligence, other than presumably the person that controls the intelligence perceives the intelligence to be in some way friendly to them. So no, I completely reject that idea that just because a thing's intelligent makes it somehow friendly.
Some people believe that something like artificial general intelligence is just too good to be true, and therefore believes that it cannot exist.
Well, what are they saying? Genius is too good to be true? Einstein was too good to be true?
Trying to fish for
Are they
questions.
saying a wheel was too good to be true? Fire was too good to be true? Aeroplanes are too good to be true? It's silly.
Okay, here's one. There seems to be, even between optimists that believe that AGI is possible, in the research community, seem to show disagreement about the optimal pathway to artificial general intelligence. But they've all got a common goal. But what do you see as the similarities between different researchers' opinions on how to get to general intelligence?
Well, I think we probably all agree that faster computers are better. That would be one of the most common ones, that the more processing power we have to throw at the problem. Look, in the same way that some software now, operating system, people often level this criticism at Microsoft, are full of bloatware, but of course they're completely covered up by this enormous speed of modern processors. They get the job done. You try running Windows 7 on a 1999 PC and it won't go very far. But so to me it doesn't, all these different directions and areas of research into artificial general intelligence or AI in general, they are also being subsumed by faster and faster processing speed. It doesn't really matter. And ultimately, when it comes down to searches, a brute force search is going to do just as well as a heuristic search if you can afford to spend the extra couple of seconds for it to finish. And those number of seconds it takes to finish are getting shorter and shorter as per Moore's law. Every 18 months they're halving. So I don't think it really matters that much. Surely the biggest commonality, though, is that they're all hungry for processor speed. Because the more the processor speed, the more algorithmic grunt they can throw at their problems, the more work they get done, the more research they get done, and the nearer they get to an objective.
What about the software problem? Do you think there's any particular points in software development that will, or the artificial intelligence software that will have big impact on?
Well, okay. The answer is, well, how many different pieces of software are running in the human brain? And the answer is, well, hard to find. If we were to model the human brain, there would be lots of subsystems that we would need to model if we want to make it exactly like the human brain. But if we wanted to model processing, as in if we wanted to create a neural network, the software doesn't really enter into it because it's really just a massive structure, and each neuron operates in effectively the same manner. The same is true of Bayesian nets. We make them large enough, then there is no software requirements. Software requirements really come in as when you start to look for heuristics, when you start to say, how can we make that more efficient? That's when you're starting to get a structural requirement that requires some specific piece of software. But if you look at the problem in terms of a massive problem-solving neural net, which I think you could do, and I think that's what will happen, and we will simply throw very large neural nets at these problems, and we will start to see solutions simply because of the sheer size of the network that we're throwing at the problem. Then if we accept that, then software doesn't enter into it. It's not a software problem because we already have the software to create those self-learning nets, to create Bayesian nets of arbitrary complexity. What we need perhaps is ancillary software such as cloud-based computing and network operating systems that allow us to quickly join our virtual and real processes together to provide grunt to build our giant neural networks. But the actual software of the system itself, no, it's just an adaptive learning algorithm.
Okay. Should the government or should governments be funding large-scale development in these areas?
Should the government be funding it?
Yes.
Well, they are. The government are funding universities, and that's where most of the work's done.
But I mean direct funding. Should the government be funding artificial general intelligence research directly?
Well, would I... Okay, that question is twofold. Would you say that I would be encouraging the government to do that? Yes. Should the government be doing that? Well, I am a supporter of democracy, and the government is our government is democratic, and we tend to be doing what we should be doing. So just because they don't take my advice and throw all this money at AI, well, that's just democracy in action. So I can't really fault it in that respect. But for the long-term competitiveness of this or any country, then the increase of the intelligence of the population, which in the past has been through education at birth rate, but the increase in the the intelligence of the population is obviously proportional to the success of the country historically. If we look at countries that seem to have good education and fairly well rich, they seem to be pretty productive and pretty successful. Look at Switzerland, for instance. So given that AI is just increasing the amount of intelligence resource available to the society, then clearly it would be something that should be on the horizon, should be being looked at. And I think it is. Possibly the government have got their own issues. They have to balance political exigencies with with, and the other problem is that many of the politicians are perhaps not as scientifically educated to recognise the ramifications of these things, and they have more immediate crisis on hand, global warming, things of that nature that they see as something that is tangible. They understand it and has to be done now, and that there's a political sentiment to get something done. But given the threat that AI poses, that if a unfriendly competitor were to have it before you, and I don't necessarily mean militarily unfriendly, it could be simply trade, or it could be criminal. But given the threat that an unfriendly entity may have if they were to get hold of AI, then I think it serves our national security and our economic well-being if we invest in this area.
Good. All right, so for the average person walking down the street who doesn't have a degree in computer science, let alone one in AI, what are the sorts of evidences in the world around them that would indicate that a singularity is likely to occur soon? What sort of...
I think, Adam, singularity has got a fairly tight definition. It's, and from the AI perspective, I think in terms of an artificial intelligence singularity, that is where artificial intelligence creates artificial intelligence, and we as humans lose control, or should I say lose understanding of the process of creating new intelligence, and possibly can never understand it, that it becomes beyond our understanding. Now that's my idea of a singularity. So it's an AI singularity. And apart from the occasional science fiction story, and if the thing ever comes up in movies like The Matrix, which sort of touched on a type of pre-singularity world. But I think that all they're going to see is their mobile phones getting smarter and smarter each generation, and each generation mobile phone, which comes out every 12 months or so. And that as they get smarter, they find themselves being more productive, because all the apps can now do quite clever things. That's their intro to AI, is through their local technology, that they'll, in the not too distant future, when they ring up Telstra, they'll be talking to Watson's cousin, and it will be answering their questions, and they'll think, oh, that's actually now useful. Not like that horrible thing that they used to have before, that kept asking you to say things over and over again and had obviously a very narrow range of input. But this thing will be conversational, engaging, friendly, or at least seem to be. And then they'll see it. But I don't, other than, I doubt very much that they'll ever sit down and sort of think about this idea of us losing control of our own creations, except where it's presented to them in a kind of rewrite of Frankenstein, something of that nature.
It seems so in the movies, like Avatar and some other ones, like there's been a new one called Limitless. All these transhuman and arguably intelligent sort of software ideas are being sort of presented to the public.
None of those
People
really
have
touched on a singularity type event. I mean, you could argue that the end of the Matrix did, when but of course it always ended up leaving humans in a happy state. Right? It was always at the end of the film, even in Avatar, the big blue aliens looked happy, and some kind of balance and was restored and conserved. Existing state was conserved, but of course the singularity is not like that. But that to say, the singularity, I think a lot of people go too far with the singularity. They seem to think that a singularity, if it occurs, will somehow break physical laws, and suddenly the AI entity, as of course, if we go back to Neuromancer, in the book Neuromancer, of course, he ended up with the AI entity, the post-singularity creature in that, communicating with its own kind, some interstellar communications or something. Now, I think Gibson was very prescient in this in his book, for sure. But this ability that they're talking about of singularities suddenly talking to other singularities is all presupposes that the speed of light is not an absolute. Breaking a singularity, reaching a singularity, doesn't mean physical laws fall off and fail. It's still going to take 8.5 minutes from light to get from here to the sun. And if you ask the singularity what's happened on the far side of the sun today, it's never going to know that unless, well, so right now, unless it might ultimately be able to model the sun, thus have a good prediction of what's going on. But it's never going to be able to tell you things that it has to break physical laws in order to know, if that makes sense.
Mm-hmm.
So I think, and because of that, because of those physical laws, there will be time constraints on its operation. It may not be it may not be as omniscient as people would expect. I mean, I certainly know a lot about humans and human literature, and probably most certainly will be able to outsmart everyone at chess. But when they talk about this runaway explosion of intelligence, I mean, there might be a good reason why it takes us 20 years to become functional in our society, because you may have to experience that much society in order to model it sufficiently to be like that. So the post-singularity intelligence, presumably, once it has modelled our society and can engage us, it doesn't mean that it is somehow supernatural. It cannot break physical laws. It cannot, say, bend time. Maybe it can. Maybe its deeper understanding of those laws will find some means to do things which are indistinguishable from magic to us. But maybe not. It doesn't guarantee it. Simply having a singularity doesn't somehow guarantee magic. It just guarantees intelligence being applied to problems. That's all.
Okay. Do you think there's quite a number of laws of physics that we haven't discovered yet that will allow faster than light travel, or not things travelling faster than light, but getting to places a lot more quickly, perhaps without travelling? For instance, to another spiral, like the next spiral arm in the galaxy, for instance.
Do you remember those early Cray, the X-1 Cray?
I don't remember them,
sorry,
but I have read them. I've read about them. Seen pictures? No.
Yeah, do you remember the shape of it? A sort of circular set of seats with a column in the middle? It was like a ring of seats, and right in the centre was a circular black tower. Not very big. The reason they were like that shape, was because of the speed of light. The speed of light affects computation. When you're trying to get massive computation, the speed of light becomes significant. And it does slow down the speed at which you can compute things. And it has to be factored in. Now, so that said, the existence of a singularity or singularity type event doesn't mean that extends to infinity beyond that. Things might level off. We might end up with a hyper-intelligent machine which cannot get more intelligent or can only get more intelligent at the rate that it can acquire information. And that rate at which it can acquire information is dependent on factors which are not within its control. It is not omnipotent. It's not even omniscient. So, whilst we might very quickly exponentially come to acquire knowledge of the world around us, it would asymptote to that knowledge of the world around it. It wouldn't necessarily go leaps and bounds on into an unknown and unknowable future to us. I don't know, it's just speculation as to what happens. Do I think we'll get to a singularity? That is, where computers can then design computers better than themselves? The answer is clearly yes. We're already using computers to design computers, although we factor largely in the development process. But we factor less in the development process than we did 10 years ago. So I think it's quite reasonable to expect our factoring in a process to diminish over time, until one day to diminish to zero. And at that point we are then at a singularity type event. But it doesn't have to be the sort of runaway techno-rapture that a lot of people are professing it to be. I see it as more of a coming of age. No, I see it more
growing
as
from adolescence.
I think it'll happen, but just don't expect fireworks when it happens. Right? It's still going to take time to get products to market, for instance, if there is a market. It's still going to take time to move things around. I mean, sure, we can see advantages in virtual worlds. If we get a handle on consciousness, you'll see uploading. And all these will have profound sociological impact, of course. But I think too much speculation is not good. It's just science fiction for the sake of science fiction. I think we can say it will be disruptive, and therefore we should look at it, and we should look at it seriously and try and understand it, and try and keep pace with it, and certainly make it friendly, you should call it. Certainly constrain it in some kind of way to ensure that it's going to behave what we would consider ethically after it comes into existence, after it's, if it's like if you throw something, you want to know which way it's going when you throw it. Right? Now it's okay with a rock or something, it just follows the laws of physics, but we don't know the laws until we can understand things like consciousness, what might motivate such a creature, until we can ensure that it will follow our nice projected trajectory and maintain itself in a way that makes us feel good and does nice things to us. Better be a little bit careful about throwing it. Right? So, yeah, I think that too much speculation can be a bad thing, but at the same time, I think it's very necessary that we do discuss it. We do look to what constraints need to be put on it. We need to monitor other people doing it so that other people don't make the mistake that they don't create an unfriendly AI, which could have negative consequences. But I tend to not want to engage in the sort of rampant post-singularity speculation that a lot of people increasingly want to do.
Awesome.